Welcome to our physics lesson. Today, we're going to explore Newton's three laws of motion. Sir Isaac Newton was a brilliant scientist who lived in the 17th century. His laws of motion help us understand how objects move and interact in our everyday lives, from driving cars to playing sports. Let's break down each law and see how they apply to everyday situations. Newton's first law, also known as the law of inertia, states that an object at rest stays at rest, and an object in motion stays in motion with the same speed and direction, unless acted upon by an external force. Let's see a real-life example. Imagine you're on a bus holding a cup of coffee. When the bus suddenly stops, what happens to your coffee? The coffee continues moving forward even though the bus stopped. This is because the coffee wants to maintain its motion. That's inertia. That's why the coffee spills in the direction the bus was moving. Your body experiences the same thing, which is why you feel a jerk forward when a vehicle stops suddenly. This is also why seatbelts are so important. They provide the force needed to stop your body from continuing its forward motion during a sudden stop. Newton's second law states that the acceleration of an object depends on the force applied to it and its mass. This is represented by the famous equation: force equals mass times acceleration, or F equals ma. Let's think about pushing shopping carts at the grocery store. If you've ever pushed both empty and full carts, you know there's a big difference. With an empty cart, which has less mass, a small push creates a lot of acceleration. It moves quickly and is easy to control. But with a full cart that has more mass, the same push creates much less acceleration. The cart moves slowly and requires more force to get going or to stop. That's Newton's second law in action. More mass requires more force to achieve the same acceleration. Or mathematically, if we increase the mass, we need to increase the force proportionally to maintain the same acceleration. Newton's third law states that for every action, there is an equal and opposite reaction. This means whenever one object applies a force on a second object, the second object applies an equal force in the opposite direction on the first object. Let's consider a person standing in a small boat. When the person jumps forward toward the shore, what happens to the boat? As the person pushes forward off the boat, they exert a force on the boat. According to Newton's third law, the boat exerts an equal force back on the person, but in the opposite direction. This makes the boat move backward as the person jumps forward. This same principle powers rocket launches. The rocket pushes hot gases downward with tremendous force, and the gases push back on the rocket with equal force, propelling it upward. A simpler demonstration is a balloon. When you release a balloon, the air rushes out in one direction, and the balloon flies off in the opposite direction. Let's quickly recap Newton's three laws of motion. First law: an object will stay at rest or in motion unless acted upon by a force. That's inertia. Second law: force equals mass times acceleration, showing how an object's mass affects how easily it accelerates. Third law: for every action, there is an equal and opposite reaction. Forces always come in pairs. Which of Newton's laws have you noticed in your daily life? Maybe when riding in a car, pushing a shopping cart, or even just walking. Thanks for watching. Subscribe for more fun science lessons.